Okay, I've got a large magnet here and also a coil of wire. This is just the copper wire that's wrapped around this form here, and the two ends, the wires here. So this is arranged that it can actually sit on the top of the magnet here. So it just slides in between there. And you see, nothing particularly special about that. But what I'm going to do is connect the two ends of the wires together. And I can do that just by linking a little loop of wire. And now watch what happens. So all I've actually done there is connect our coil. This is our coil of wire, and connect our two ends together in a circuit. Tip it slightly to see it. So something is stopping that coil moving, and in fact there's actually a bit of resistance for me to lift it off. Without the circuit made, there's nothing slows it down. So a bit like we saw with the pipe earlier in the previous video, this is generating an electrical current in the coil which is opposing the magnetic field. So if we're making electricity, can we detect it? So this time I've got some LEDs. We've got two light emitting diodes, there's a blue one and a white one. And if I drop the coil through, you see one flashes. When I remove it, another one flashes. So it's directional. There was the left one flashed on the way down, and the right flashed on the way up. So it was, and also that was the white on the way down, blue on the way up. So we're generating electricity in there as well. Because basically we have a generator here, so this is effectively the way electricity is still produced, whereas a coil is cutting through a magnetic field. What if we connect electricity, a supply to the coil rather than move the coil? Okay, I'll connect this small battery here to the coil. Notice the coil lifts itself out of the magnetic field. If I turn the battery the other way around, it's actually trying to push down the way. We've reversed it. So if I lift this out and turn it around and do that again, it now lifts itself back. So we've changed the direction of current and the way it wants to move. So again, we've got something now that's starting to look awfully like an electric motor. Okay, I've got the coil connected up to an output of an amplifier, so we're putting an AC signal into this coil. It's doing that just now, but it's quiet just now. Now bring this magnet over here and place that over the top. Suddenly you can hear music, and this is because now we've got our current in our coil interacting with our magnet, but because it's sitting on the tabletop, this is effectively becoming a diaphragm, and therefore it's behaving like a loudspeaker. And this is basically the process of how a loudspeaker works.